Our second speaker of the evening is Dr. Edward Murphy. He's a professor of astronomy here at UVA. He got his bachelor's degree in astronomy from the University of Illinois at Urbana-Champaign and his PhD from here at UVA in 1996. He was a postdoctoral fellow at Johns Hopkins University, where he worked on NASA's Ultraviolet Spectroscopic Explorer, or the FUSE project, which is a telescope that measures the gas and matter between stars. Dr. Murphy has been a member of UVA's faculty since the year 2000, where he continues to use the FUSE telescope, teaches introductory astronomy at the university, teaches evening classes at the historic Leander McCormick Observatory. Dr. Murphy gives astronomy talks and appears regularly on local radio. Tonight, he plans to answer the question, or at least address the question, of whether we are alone in the universe and why that matters. Please join me in welcoming Professor Murphy to the stage.
So thank you very much. It's great to be here tonight. My apologies to those of you that have had my COLA class over the years. I'm trying to take a whole semester's worth of a COLA class and cram it down into 45 minutes. But I teach that COLA class for a reason, because I think that this question that I've got on the screen behind me, are we alone, is actually one of the most profound questions that we're asking in the physical sciences right now. And the reason is, it's profound if for no other reason than a yes or no answer tells us something tremendous about the universe. Right? If I ask you, where are we going to dinner tonight, and your answer is yes, it's not a very profound answer. But if you look at that question and say, are we alone? And say, yes, we are. Imagine a universe filled with hundreds of billions of stars that has existed for billions of years, and we're the first and only. Or if I say, no, we're not alone, that answer is profound as well, because that means there's somebody else out there. What are they like? Do they share the same DNA that we do? Do they have the same societal problems that we do? Have they figured out how to do a better job than we have? It's a really profound question with really profound answers. And we spend in my COLA class a whole semester thinking about this. So the first thing I want to do is a little audience participation. So do you believe that we are being visited right now by an extraterrestrial intelligence? Raise your hand if you think we are. Yeah, there's a scattering of people in the audience, right? That's a tough one to admit to. Look, if you admit to it, you're not alone. This is just some interesting polling data, but you can look at over the years what people believe. Gallup polls it every now and then, and what Gallup has found up there is that sort of 27 to 30% or so of people believe that we're being visited by extraterrestrials. There are other surveys up there. 52% from that Ipsos survey believe in UFOs, 36%. 20th Century Fox in 2017 interviewed people, and 47% believed in aliens. 39% believed that those aliens have visited the Earth. That wasn't my favorite question in the survey, though. My favorite question in that survey was this one: who would you volunteer to be abducted by aliens? Right? And the answers are great. So first of all, 17% said that they would volunteer themselves. Almost 20% said they would volunteer a frenemy, right? So be careful. But the one that fascinates me at the top, almost 8% said they would volunteer their significant other, right? That's a whole bunch of conversations that need to happen if you're volunteering your significant other to be abducted by aliens. So, all right. Do you believe that there are other intelligent civilizations in the universe? Not necessarily visiting us, but they're just out there somewhere. Raise your hand if you think there are. Wow, look, that's almost everybody. And then, do you believe that there are other planets with life? Not necessarily intelligent life, but just life of any kind out there, right? So why do so many people believe that we are not alone? So most of you seem to have settled this answer in your head already. You've settled on the answer that we are not alone in the universe. And why is that? And really it comes down to a numbers game. And that numbers game primarily comes from the fact that we live in a giant galaxy called the Milky Way. This is a picture of the Milky Way galaxy taken from a mountain in eastern Arizona called Mount Graham. The University of Virginia has a share of a giant telescope that's on Mount Graham. But this is what our Milky Way looks like from the inside. It's made of a few 100 billion stars. If we could get outside the Milky Way and look back on the Milky Way from a long distance away, it would look something like this. This is obviously not our Milky Way galaxy. Humans have never been able to take a picture like this. In our lifetimes, we will not get a picture like this. With the spacecraft we have today, it would take us literally tens of millions of years to get far enough away from the galaxy to snap this photograph of the Milky Way. But there are other galaxies out there, and from our work on studying the Milky Way, we think we know what they look like. And so we think this is what our Milky Way galaxy would look like. We don't live in the center of the galaxy. We live about halfway out in the galaxy. And from one side to the other side, our Milky Way galaxy is 100,000 light years across. That means that light, traveling at 186,000 miles per second, still takes 100,000 years to cross from one side of the galaxy to the other. Think about how profoundly big that is. And on top of that, our galaxy contains, the best estimate is somewhere between 100 billion and about 400 billion stars. We're going to use a nice round number of 200 billion stars. So why do people believe that we're not alone? Well, the answer comes to this gentleman, probably his name is Frank Drake. He came up with an equation called the Drake equation. It's actually highly debated in science as to how useful the Drake equation is, because many of the things in the Drake equation we don't know very well. But let's talk about them for a quick second. N is the number of intelligent communicating civilizations in our galaxy. R is basically the number of stars. Formally, it's the number of stars that are forming every year in the galaxy. Fp is the fraction of those that have planets. Ne is the number of Earth-like planets in each system. Fl is the fraction of Earth-like planets that have life. Fi is the fraction of life-bearing planets that develop intelligence. Fc is the fraction of intelligent civilizations that develop technology and the ability to communicate. And then L is the lifetime of a civilization. Now, we're going to play a simpler version of this right now, and that simpler version basically starts with the fact that our Milky Way galaxy has 200 billion stars in it. And if only 1 out of every 10 of those stars is like our sun, that means that right now our galaxy contains 20 billion sun-like stars. Now, be pessimistic and say that only 1 out of every 10 of those sun-like stars has planets. That means there are 2 billion sun-like stars with planets going around them. The evidence that astronomers have today is actually that number is probably closer to 100% of sun-like stars have planets, but we're just being extra pessimistic right now. Imagine that 1 out of every 10 of those stars with planets has an Earth-like planet. That means right now there are 200 million sun-like stars with planets that have Earth-like planets going around them in our Milky Way. Imagine now that only 1 out of every 10 of those develops life. That means there are 20 million sun-like stars with Earth-like planets that have life. And then if only 1 out of every 10 of those develops intelligence eventually, that means there are 2 million sun-like stars with Earth-like planets that have life that develop intelligence. It seems to us that just playing the numbers game, we can't possibly be alone. There are so many stars out there, and that's just our Milky Way galaxy. If you're curious about the universe as a whole, our best estimate is that the universe as a whole has well over 100 billion galaxies in it, each one of them like our own Milky Way galaxy. So what I want you to do now is we're going to put this information aside for a second. The fact that it seems like just playing the numbers game, there should be a lot of intelligent species in the galaxy. And we're going to talk about something else. Oh, well, actually, let me do this poll real quick. So how many intelligent communicating civilizations do you believe are in the galaxy? To get the feel for the room, we're just going to do 3 votes. We're going to say you believe that we're alone, that there are a few but not many, and that there are lots. So how many people believe that there are? Let's start with, well, we'll make it tough. We'll start with the first one. How many people think we are alone, that we are the only intelligent species in the galaxy? So just a couple people. How many people think there are a few, maybe dozens or so? And how many people think there are lots of intelligent species in the galaxy? Okay, so the few seem to win out, but there weren't many people that were alone in the galaxy. Which is interesting because I didn't pay close attention, but I think some of the people who said we were alone also raised their hand earlier and said that, they thought there were others out there. So, all right, put that information aside for a second. How many intelligent civilizations are there? Because the other really cool fact about our universe is that our universe is incredibly old, at least by human standards. This is a little graphic that was put together to sort of explain the whole history of the universe. The Big Bang happens over there on the left-hand side. The universe undergoes a very rapid expansion. I'm very careful to say that it was not an explosion. The Big Bang was an expansion of the universe. There's a long period where nothing interesting is happening in the universe. Then we get the first stars and the first galaxies, and then the universe evolves from there. One of the hard-fought numbers in astronomy, which has come about in my lifetime, is actually the age of the universe. When I was an undergraduate student, when I was in your place, I was being taught that the age of the universe was somewhere between 10 and 20 billion years old, and our best estimates were that it was about 15 billion years old. By the time I was a graduate student, we'd narrowed that down. It was sort of 12 to 16 billion years old, and it was likely around 14. Now that I'm a faculty member and we've launched a satellite named WMAP, the Wilkinson Microwave Anisotropy Probe that studied the glow left over from the Big Bang, we know precisely the age of the universe. It's 13.8 billion years old. And the uncertainty in that number right now is less than 1%. You are the first generation that lives in an era where humans know the age of the universe to 1%, to better than 1%. And that's a number that's not going to change. The last digit will change a little bit, but the 13.8 is pretty solid. Let's try and put that in perspective. How can we figure out how long a period of time 13.8 billion years is, right? It's such a vast quantity of time that none of us can comprehend it. Carl Sagan faced the same problem. He wrote a great book, if you've never read it, called Dragons of Eden. You should definitely read this book. And in there, he struggled with the same question. And he came up with the idea of comparing the history of the universe to a time period that all of us can understand. And all of us understand a year, right? You've lived 18, 20, 21, or 22 of these. I've lived a lot more of them. But we all understand how long a year is. And so Carl Sagan said, let's imagine taking the 13.8 billion year history of the universe and cram it into 1 year. So he came up with this idea called the cosmic calendar. He did this primarily on a TV show that Carl Sagan did called Cosmos. Cosmos was remade a few years ago by Neil deGrasse Tyson. That's why this calendar is from 2014. This is the cosmic calendar that Neil deGrasse Tyson updated for his Cosmos series. But basically the idea behind this is that the Big Bang happens on January 1st, and today is on December 31st. How do we take the whole history of the universe and cram it into a year that you and I can understand? So, if the Big Bang happens on January 1st and today is December 31st, what are some of the important events that have happened in history? Well, we can start with, for example, the first stars. They come around in mid-January, a few 100 million years after the Big Bang. Shortly after we get the first stars, we get the first galaxies in the universe. Galaxies are a bit bigger. They take us somewhat longer to form. These are small galaxies. They're not like our Milky Way. Our Milky Way is a cannibal. It builds itself up by eating smaller galaxies. It took our Milky Way some time to form, but our Milky Way galaxy was formed by, on this calendar, mid-March, the Ides of March. What surprises most people looking at this calendar is they often think of the Big Bang as the origin of the universe, and they sometimes mistakenly think of it as the origin of our solar system, but it's not. Our sun and the planets going around our sun, including the Earth, don't actually form in this scenario until September, and in fact, right around September 1st. What's going on that whole time in between in our Milky Way galaxy is stars are being born, they're living out their lives, and they're dying. And the next generation is being born, living out their lives, and dying, and this is going on in this calendar month after month after month. In the real universe, it's going on billions of years after billions of years after billions of years, and well into the history of the universe, our sun finally forms on September 1st. Remarkably, after the Earth settles down, and the Earth cools off, and the conditions become conducive to life, life forms on the Earth, and the first life appears around September 28th. Right? Looking at the cosmic calendar, that's a blink of an eye. As soon as conditions were ripe on the Earth, life appears. That life gets complex fairly quickly. So not long after, by October 2nd, we have complex biochemistry. We have organisms that are able to use photosynthesis to generate energy using photosynthesis. They're able to store that energy. Up until this time, most of the life on Earth was chemosynthetic. probably living at vents down at the bottom of the ocean and other places where it could draw energy from chemicals. But under photosynthesis, they're now, with this complex biochemistry, able to take advantage of the sun. Thanks to this photosynthesis, oxygen starts to build up in our atmosphere. You and I don't think of it this way, but most of the microorganisms on Earth think of oxygen as a terrible poison. It builds up in the atmosphere, and it finally reaches significant levels by the end of October. And then as we continue our cosmic calendar, we get complex cells showing up for the first time on November 9th, eukaryotic cells. Up until this time, they were simple prokaryotic cells, really simple cells. They didn't have a nucleus, they didn't have organelles, but on November 9th, the first complex cells show up. Now think about that. Today is December 31st. The Earth formed on September 1st. We're more than halfway through the calendar before we even get complex cells, and we're still dealing with single cell life. We don't get, well, I'll talk about this one in a second. We get sexual reproduction on November 29th. That's important because up until this point, organisms on Earth are simply copying themselves, and they're making a copy and making a copy and making a copy. Now, for the first time, we have two organisms with two separate genomes, combining those genomes, and it opens up a lot more opportunity for evolution and change to happen. So that happens on November 29th. We get our first multicellular life in December. The Earth formed on September 1st. Today is December 31st. We don't get our first multicellular life till December 5th. One of the most remarkable events in the history of life on this planet is the Cambrian explosion, and that happens on December 17th. If you've never heard of the Cambrian explosion, you should read the book A Wonderful Life by Stephen Jay Gould. It's all about the Cambrian explosion. It was a diversification of complex life on Earth like we have never seen before and have never seen since. All of the phyla that exist on Earth today existed on December 17th, on that day, at the time of the Cambrian explosion. There were lots of phyla that existed then that have since gone extinct, but since that time, no new phyla have evolved on the surface of the Earth. Our phylum, which for those that don't remember is Chordata, because we have a spinal cord, we see the first chordates in the Cambrian explosion. These little almost worm-like creatures that clearly have a spinal cord running down their back. The dinosaurs appear on December 25th in the cosmic calendar, and the dinosaurs do fantastic because they last all the way until December 30th. They last 5 whole days on the cosmic calendar. That's the age of the dinosaurs. Everything that we think of as history occurs on the last day. And it not only occurs on the last day, but as Carl Sagan said, it occurs in the last few seconds of the last few minutes of the last day. This is the last day on the cosmic calendar, December 31st. We get early hominids appearing around 9 o'clock in the evening. Modern humans show up at 11:58, 2 minutes before midnight. Human beings developed agriculture 25 seconds ago. The pyramids were built 11 seconds ago. Kepler and Galileo showed that the Earth is going around the sun and not vice versa 1 second ago. And then now is midnight on December 31st. So just to emphasize that Carl Sagan quote, "We humans appear on the cosmic calendar so recently that our recorded history occupies only the last few seconds of the last minute of December 31st on this calendar." Our galaxy is incredibly ancient. Now, how can we put these two facts together? There seem to be a lot of stars. There seems to be the possibility for life, seems to be the possibility for a lot of intelligent life, and our galaxy is ancient. How might these be related to one another? Well, the answer to that comes from thinking about a fellow by the name of Enrico Fermi, one of the great physicists of the 20th century. He was an Italian physicist, came to the United States right before World War II, was absolutely essential in the development of the atomic bomb, worked at the University of Chicago, worked at Los Alamos National Lab after the war. And it was one day in the spring of 1950 at Los Alamos National Lab that Enrico Fermi was talking to some of his colleagues at Los Alamos National Lab. One of those colleagues was Edward Teller, who was the father of the American hydrogen bomb, Emil Konopinski, who was another famous scientist. And they're talking about the headlines in the newspapers. because the headlines in the newspapers were dominated by two interesting stories. And those two interesting stories was, one, a rash of UFO sightings, and two, for some weird reason, the trash cans in New York City were disappearing. And Emil Konopinski brought it to their attention that Alan Dunn, who was a cartoonist in the New Yorker, working for the New Yorker, had published a cartoon that explained both of these things really well, that the aliens were stealing the trash cans. And as a joke, Enrico Fermi said, you know, that's actually a really reasonable hypothesis. Because sometimes in science, when a hypothesis explains two disparate phenomena, it's a really powerful indication that you're on the right track. Now, he was just joking about this, but they went on to talking, and Enrico Fermi asked Ed Teller, what do you think about traveling faster than the speed of light? When do you think it will be possible? Do you think it'll be possible in the next 10 years, by 1960? And Ed Teller said he thought that the chances were 1 in a million, and Enrico Fermi said he thought that was too pessimistic. He thought we would learn about faster than light travel within the next 10 years. He thought the chances were much better than that. So the conversation moves on to other things. All four of these colleagues, they go to lunch, they sit down at lunch, and right in the middle of lunch, without any prompting at all, Enrico Fermi stops, he looks at his colleagues and he asks, where is everybody? And they immediately understood what he was asking. Enrico Fermi, in those few minutes he was sitting there at lunch, had worked out the same things we had just worked out in our heads. That it seems like intelligent life in the galaxy should be common. And the galaxy is ancient. And what Enrico Fermi realized is that if you can travel at just 10% the speed of light, you can cross our Milky Way galaxy in 1 million years. And on the cosmic calendar, that's 1 hour. Enrico Fermi realized that if an intelligent civilization had ever developed in the Milky Way galaxy and had developed the ability to travel between the stars, as we routinely picture in Star Wars and Star Trek and whatever your favorite science fiction is, they can travel across the galaxy in an hour. In a day, they can crisscross the galaxy 24 times. In a few days, they can conquer the galaxy. Why haven't they done it? Why aren't they here? Why have they never come to this planet? Because frankly, if you are a water-based organism like we are, the Earth is the ideal planet. And if you are looking for a place to settle, if you are looking for a place to come start a colony, you're not going to find any place better than the Earth. So why is it, if they had billions of years, and there are millions of civilizations out there, why did none of them show up here? By the way, I don't think it's an ethical question as to why they didn't conquer the Earth, because remember, for most of our life, most of the history of life on this planet, we're dealing with little single-celled organisms. I don't think that they're going to have an ethical problem showing up and displacing a whole bunch of single-celled algae in the hope that someday they will evolve into us, right? So why did they not, well, let me use Enrico Fermi's question, where is everybody? Now, there are a bunch of solutions that have been proposed to this. This is what we spend the semester in my COLA class exploring. So one of them is that maybe they are visiting us, right? Maybe we're not alone. There was a scattering of people at the beginning who thought that maybe they are visiting us. And as I said, you're not alone. About 30% of Americans believe that we are being visited by extraterrestrials. If that's not the case, there are a couple of really important things. Maybe we're the first. Maybe we're the first intelligent civilization in the history of the galaxy. Think about that. Hundreds of billions of stars over billions of years, and maybe we're the very first ones ever. That makes us very, very special. But I think what makes us even more special is maybe we're alone. Maybe we're the only ones in the whole history of the galaxy. And that also makes us really special. And for those reasons, I think that this question of are we alone in the universe has really important implications for our everyday lives. People think of astronomy, and you often think of things that are millions of light years away that happened billions of years ago, has no practical impact on your everyday life. But I think there's a lesson here in this question of are we alone, and it has practical implications. It tells us something about the universe which could be very important to us here on Earth. And that's what I'm going to spend the rest of this lecture exploring. So, back to this idea that maybe they're visiting us. So this is sort of the evidence that we're being visited by extraterrestrials. This is an old photograph that goes back to the 1950s. You can search YouTube You can find lots of evidence on YouTube. You can find all kinds of videos and things like that. So how do we evaluate these claims? What tools do we have in science to evaluate whether being visited by extraterrestrials or not? The Scottish philosopher David Hume gave us exactly the tool that we need, and he gave us this tool way back in the late 18th century. And he said this: "No testimony is sufficient to establish a miracle unless the testimony be of such a kind that its falsehood would be more miraculous than the fact which it endeavors to establish." That's a complicated way of saying it. Carl Sagan said it, I think, much more elegantly. Extraordinary claims require extraordinary evidence. Is this the extraordinary evidence that we need to back up the extraordinary claim that we're being visited by extraterrestrials? And I don't believe that it is. I don't believe that it is for a number of reasons. First of all, most of these photographs are shown to be faked. There's lots of evidence that aliens, well, one of the reasons that we think they're faked is one of the cool things about aliens is they actually care about our aesthetic sensibilities. Because if you look at the UFOs back in the 1950s and 1960s, they were sleek, they were made of stainless steel. If you think back to the aesthetic of the 1950s, things were sleek, they were made of stainless steel. But now that our society has changed, they have changed too, so the UFOs look a lot more like what we see in our science fiction today. So this is a video off YouTube about a UFO that they saw in Haiti, which has been proven to be a hoax, by the way. But that's interesting. UFOs teach us, I think, much more about ourselves than they teach us about the universe as a whole. But in any case, do I believe that this is the evidence that we need to prove that, that aliens exist? I do not. One of the primary reasons I don't believe that it exists is because of basically a significant change in society that I don't think we often appreciate how important this is. And that is the fact that each and every one of us carries with us, everywhere we go, a really, really good digital camera, right? And if UFOs really existed, and if we were being visited as often as the media, the History Channel would tell you, shouldn't we have thousands upon thousands of photographs of UFOs? I mean, really good pictures of UFOs, because if you believe, you know, the media, but not the media in general, but UFOologists in particular, we're being visited dozens of times a day. UFOs are seen everywhere, all around the world, every day. Why don't we have good pictures of them? Why are all the pictures things that are clearly faked? I'll give you an example of something that very rarely happens. Thank goodness it very rarely happens, because it's a terrible thing when it happens. But it happens every now and then, and when it happens, people have the presence of mind to get out a camera and snap a photo. And this, on average, by the way, happens about once a year worldwide. And about once a year, an airliner crashes. And every now and then, surprisingly often actually, people have the presence of mind to get out a camera and snap a photo of the airliners that's going down. How can this happen once a year and we get pictures of it, but UFOs are visiting us all the time and we never get pictures of it? I sincerely hope that if an alien walked through that door and came up to shake my hand right now, at least some of you would have the presence of mind to get your cameras out and videotape it for posterity, right? If you ever get kidnapped on a UFO, do me a favor, take a picture, right? Take a selfie with you and the alien. Just make sure that it's clear enough that it doesn't look blurry like most of the UFO photos are. It doesn't look like you could have faked it. By the way, this is also evidence to me that Bigfoot doesn't exist, right? Where are all the good photos of Bigfoot? The Loch Ness Monster? Ghosts? Ghosts don't exist. If ghosts really existed, we would have thousands upon thousands of pictures of ghosts, right? Pretty much any of these things that you think about, we should have lots and lots of good pictures of them if they really existed. So, I know what you're saying. You're saying, wait a second. Didn't we back in 1947 capture an alien in Roswell, New Mexico, and autopsy the alien to see what was inside it? And the answer is there's very, very good evidence that the alien autopsy video is faked. In fact, a number of the people who were involved in it have admitted to faking it. So in fact, we have no good evidence that we captured an alien in Roswell, New Mexico. And in fact, when I have looked, and I've looked extensively at all the data on UFOs and alien encounters and abductions and alien autopsies and things like this, it's an extraordinary claim that we're being visited, and no one has yet presented the extraordinary evidence that proves that we're being visited. And so as a scientist, I look at this and I think to myself that we are not currently being visited, and I look at the evidence. I do not believe that we have been visited in the past. I don't believe that there's any evidence that they built the pyramids, that they built the Nazca lines, that they built the pyramids in Mexico, the Mayan pyramids. I don't believe that aliens have ever visited the Earth. So, where is everybody? If the galaxy is billions of years old and there are lots of intelligent civilizations and they're not visiting us, where are they? People have come up with lots of ideas to explain why it is that we appear to be alone in the galaxy. In fact, they've come up with dozens upon dozens of ideas. So one of the ideas is that we happen to live on a particularly special planet. It's called the rare Earth hypothesis. And there are lots of things to think about with the rare Earth hypothesis. So basically, it just says that the Earth is a really special place. One of the ideas is that we live in a very special place around the sun. If you get too close to the sun, it's too hot for liquid water to exist. If you're too far from the sun, it's too cold. The liquid water is solid. One thing that we do know about life on Earth is that all life on Earth requires liquid water to survive. So we are in that magic zone that astronomers call the habitable zone. You'll often see in the media it's expressed as the Goldilocks zone because it's just right. One of the problems with the habitable zone is that over time it moves, but planets don't. As our sun, when our sun started 4.5 billion years ago, way back on September 1st on that cosmic calendar, our sun was much cooler and much dimmer than it is today. Our sun's been getting hotter over time, which means that the habitable zone earlier was much closer to the sun, and over time, that habitable zone has been moving outwards. But what's quite clear from the geology on Earth and the history of life on Earth is that the Earth has managed to be in that magic spot where we have been continuously in the habitable zone for 4.5 billion years. And will be, by the way, in the habitable zone for about another billion. So the danger, though, for us is after 1 billion years, the Earth will find itself outside the habitable zone as our sun continues to warm up. That is not the cause of global warming. That's a completely different issue. The warming of the sun happens on scales of billions of years. Global warming is something that we've seen happen on very, very short time scales. But we do, in the long term, this might limit the possibilities of life on planets. The fact that you can only be in the habitable zone for a short period of time. Solar systems are a really violent place, can be a really violent place. We may owe our existence on this planet to a random asteroid strike about 65 million years ago, wiping out the dinosaurs and allowing those little furry creatures that were living underground to become the dominant species on the planet. It might be that on most planets, as life develops and life gets complex, that bombardments happen often enough that they just continuously wipe out the complex life, and then life has to start over again, and as it gets starting complex again, you might get another one of these random events, and we just happen to be in a long, quiet period where we have not had an event large enough to wipe out life on Earth. Maybe solar systems are dangerous places. One of the things we don't often think about is the Earth is unique in our solar system. We are the only planet that has plate tectonics. It's fascinating because Venus is 95% the size of Earth. It's almost the same mass as our planet. In many ways, Venus should be an identical twin to the Earth. But in one really fundamental, important way, it's different. And it's different because it doesn't have plate tectonics. And plate tectonics may very well be essential to the formation of life on Earth, if not complex life on Earth. I mentioned earlier that the first organisms that may have existed on Earth survived around volcanic vents down at the bottom of the ocean, which are related to plate tectonics. Many millions of years ago, our Earth went through a global freeze where the planet as a whole completely froze. And what defrosted us, what saved us from that global freezing, was volcanoes spitting out carbon dioxide. That carbon dioxide building up in the atmosphere, creating a greenhouse effect, which warmed the planet back up again. Maybe without plate tectonics, you wouldn't have life, and certainly not complex life. And in our solar system, the Earth is unique as the only planet. So maybe the Earth is rare because we have plate tectonics. Maybe it has to do with our moon. When it comes to planets in the solar system, our moon is not the largest moon in the solar system. It is on the larger side of moons. But what's most important is that our moon is much larger compared to its parent planet than any other body in the solar system except Pluto. So Pluto has a moon that's a little bit larger. Its moon is smaller than our moon, but compared to Pluto, it's larger. Tides may play an integral role in evolution and early life on Earth. If we didn't have a moon and we didn't have tides as large as we have today, maybe we wouldn't have life on Earth. The moon also plays an essential role in stabilizing the tilt of the Earth. The Earth is tilted over by 23.5 degrees. Our moon keeps us within a few degrees of that. A planet like Mars, which does not have a large moon, Mars can change all the way from being straight up and down to almost 90 degrees over. Over the time period of millions of years, Mars flips back and forth. Its pole wanders, and it can go through many, many different tilts. But on the Earth, our tilt has held constant for a long period of time, thanks to our moon. There are other evolutionary thresholds, building on what we heard earlier, this idea of thresholds and the importance of thresholds. Maybe the genesis of life is rare. Maybe life just rarely develops on planets. Maybe the prokaryote-eukaryote transition is rare. Maybe it's not too hard to get simple cells, I should say, but that getting complex cells is really difficult, and that we were one of the few places to accomplish that. We could go all the way up to the fact that maybe intelligence at the human level is rare. Or maybe intelligence isn't rare, but maybe it has something to do with language. You can argue as to how many intelligent species there are on the surface of the Earth, but without a doubt, humans are the only ones that have developed a language that is complex enough to pass on abstract ideas from one generation to the next generation. Absolutely essential to our development, and maybe that's a fluke of evolution that doesn't often happen. Maybe it has to do with technological progress. Maybe you can have a civilization that has language, but for one reason or another, they just get stuck. Imagine a civilization that's stuck at the Roman Empire stage, and they just never managed to get past the Roman Empire and never developed the technology that we have today. There are other ideas. Maybe spaceflight amongst the stars is really difficult, a lot more difficult than we believe. A lot more difficult, certainly, than science fiction tells us, right? Science fiction tells us that you get on the bridge of the Starship Enterprise, you say engage, and the starship flies off at much faster than the speed of light, and you can be around the galaxy in no time at all. Spaceflight's a lot harder than that. This is the Voyager 1 spacecraft. It's the most distant spacecraft we have. It was launched back in 1977. This year it will celebrate its 42nd anniversary in space. The Voyager 1 spacecraft right now is about 20 light hours away from us. It takes light about 20 hours to get to us from Voyager 1. Another way to put that is if we send it a signal right now traveling at the speed of light, it takes 20 hours for that signal to get out there. It says, yes, I heard you. It responds. It takes 20 hours for the signal to come back. The round trip time is 40 hours to hear back from Voyager 1. So think about that. If we sent a signal right now on Thursday evening at about 7 o'clock, we wouldn't hear back for 2.5 days from Voyager 1. And the whole reason is it takes light that long to get out there and come back again. Voyager 1's about 20 light hours away. The nearest star is 4.5 light years away, the nearest star other than our sun. To put that in perspective, at the speed that Voyager 1 is traveling right now, it's going to take 75,000 years to get to the nearest star. I'm not going to live to see the day that humans explore even the closest star to our sun. But you're not going to live to see that day either. And no, because it's 75,000 years away. And your children's children won't live to see that day. That's how far away the stars are. They're so far away that even with the technology we have now, it's 75,000 years. And I know you're thinking, yeah, but our generation's going to do a lot better, and I know that you will. Imagine you build a spacecraft that can go 10 times faster than our fastest spacecraft today. It's still going to take you 7,500 years to get to the nearest star. You're not going to live to see it. That's how far away the stars are. This might be how humans eventually colonize the galaxy. This idea called generation ships, where you build not small spacecraft, but you build these giant monstrosities that have everything that humans need to live. they have water, they have land, everything. You load it up with people and you ship it off. And you ship it off with the intention that the people who are on the ship the day that it leaves know that they won't leave to see the day that it arrives. And they will have children who will live their whole lives on that ship. And their children will live lives on that ship and on, generation after generation after generation, until eventually, thousands of years in the future, that ship arrives at some distant star system and they colonize it. That's the only hope that we can imagine, and this is far, far beyond any technology we can imagine doing today. So really, that's a remarkable technology that we just don't have. What about communication? Communication across interstellar distances is also really difficult. We don't know where they are in the sky, right? My cell phone works well because the engineers who designed my cell phone also worked with the engineers that designed the cell tower. They agreed ahead of time on the signal strength that my phone would have and the signal strength that the tower would have, the frequency that my phone would work on and the frequency of the tower, where the towers are, where the phones can be. We agreed on all this stuff. That's what makes communication possible. In the case of extraterrestrial civilizations, we don't know where they are in the sky. We don't know where they are in the universe. We don't know what frequency they're broadcasting on. We don't know when they're broadcasting. We don't know how they're broadcasting. Searching all of that parameter space to try and find an extraterrestrial civilization is worse than finding the needle in a haystack. And this is often called the needle in a haystack problem. It's an almost intractable problem. People are attempting it today, but the odds of success, I think, are incredibly low, just because there's so much that we don't know. Could be that everyone out there is listening and no one is transmitting. Wouldn't that be a shame? Everyone has built radio telescopes like this to listen in, to see if we can listen on conversations, but nobody's intentionally transmitting. Why might they not be transmitting? Well, it turns out transmitting could be really dangerous. When you think of aliens, you might think of E.T. E.T. was cute, he was friendly, he had that finger that lit up and it would cure your ills. If you were sick, he would just touch you with the finger and things would get better. That may be what aliens are like, I don't know. On the other hand, if evolution and the history of humanity tells us anything, I think it's far more likely to be this, Independence Day, right? So if they have spent a phenomenal amount of time and energy and effort to get across the galaxy and they show up here and they were intending to form a colony here, I think it's far more likely that it's going to be this than it's going to be E.T. So maybe transmitting is dangerous and other societies have chosen not to transmit. That's why we don't hear from them. Okay. There's a way to think about organizing all of this that was developed by Robin Hanson. He's an economist at George Mason University. And the idea that he came up with is he realized that in the course of history, to go from a planet with water on the surface to a civilization that is able to colonize the galaxy, there are a number of evolutionary steps or thresholds that you have to overcome along the way. So you start over here with this planet that has liquid water on the surface, and then the first evolutionary step is simply the formation of life. And then you probably need life with complex biochemistry. And then you probably need eukaryotic life or some kind of complex cells. And that eventually leads to sexual reproduction, which leads to multicellular life, which leads to the next step, 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 to the next one, until finally you get a civilization that is capable of interstellar colonization. The advantage to interstellar colonization is once you have colonized multiple star systems, it's very difficult to wipe out a species, right? If we had colonies on other stars, then even the death of the sun won't end humanity because we have colonies out at other stars. And as stars start dying and they become inhospitable to life, we can just move to other star systems. The idea that Robin Hanson came up with is that maybe one of these steps is a lot harder than the others. Maybe we get another planet that's just like the Earth, and the formation of life is really easy, and the formation of complex chemistry is really easy, and the formation of eukaryotic life is easy, and sexual reproduction is easy, and multicellular life, and all these other steps. And I don't know that this is the right number of steps. I don't think anybody knows the number of steps. I don't even think those are the important steps. It's just that there are these thresholds you have to overcome. But maybe there's one threshold that's so hard that they just can't get past it. And you can imagine another planet out there, and that threshold is so hard that that planet just can't get past it. In fact, that threshold is so hard that many planets, just like the Earth, develop, and they can't get past that. And Robin Hansen came up with the idea of something called the Great Filter. The Great Filter is an evolutionary threshold, a step that everybody has to cross to make it to the right-hand side, to be an interstellar, a species capable of interstellar colonization. And we don't know what that step is. If that step is really hard, it might be that civilizations only very, very rarely get across that step. The question is, where are we today with respect to the Great Filter? Because if the Great Filter is in our past, if it was sexual reproduction, if it was multicellular life, if it was complex animals, if it was the development of human intelligence, if the Great Filter is behind us, then we are very likely to become an interstellar, a species that can do interstellar colonization. The reason I'm giving this talk today, the thing that concerns me, is what if the Great Filter is in front of us? What if it lies in our future? What if it's nuclear war, overpopulation, global warming? What if it's biological warfare, the end of cheap energy, injustice and economic inequality or inequity? What if the Great Filter is in our near future? That's what concerns me. That's why I teach this class, to let students know that I'm concerned that the universe is telling us that there's something that prevents civilizations from surviving. And that question is that filter behind us or is it in front of us? So I wonder if the question we've been asking shouldn't be, are we alone? But is the question we should be asking ourselves is, how long do we have? Now, I'm not without hope, and I'm not without hope because of all of you. You are the future. I'm serious about this. It is my great honor and privilege to teach at the University of Virginia because I get to work with the future leaders. You are the ones that are going to make sure that if the Great Filter is in the future, we're going to find a way around the Great Filter and we're going to survive. So, thank you very much.
Guys, so much for coming out tonight. I appreciate it. Please take a moment to stop and thank our wonderful speakers on your way out. They just took some time to come and speak to us, which means the world. And also, I'm so thankful to all of you. As we talked about, both speakers talked about tonight, we are all of us on a threshold, and we took a little time on that precarious point to come and be together and hear from some really incredible people. So thank you for doing that, and of course, thank them again. So appreciate it. As I know, one or two of you may be wondering, there is food. It is outside in the courtyard. There's Roots. Is outside if you go kind of to the right when you exit the building. So you guys can feel free to go get that on your way out. We do have gluten-free and vegetarian options for those of you who need them, and they're marked. If you are not gluten-free or vegetarian, please hold off on eating those options until those who are can get a hold of them. Otherwise, you guys are free to go. Thank you. Come join us next year.